Message: Dear tutees, GuruTutoring.com team promises what you are going to discover here will be unlike anything what you've heard before. Template-oriented solution models. Message: These efforts are dedicated to anonymous combatants of knowledge. Next, Part 2. E-monograph segments envelop, object-oriented modeling OOM foundation, business rules versus object technology, OOM implementation. Continue, comparison of entity relationship ER and UML modeling, tips on enterprise modeling. Next, Segment 2, Unit 1 E-monograph object-oriented modeling foundation A. Next, Lesson 1. 1. Object-oriented models, OOM. Basic building block of E and R data models are entities physically storing data in normalized tables. Next, similar to OOM data models are the objects of same class. Next, what is an object? Objects are things of the real world. Objects have properties. The values of these properties together define the state of the object. For instance, a table of 4 legs made of wood is lying in room 109. Action on an object, created, destroyed, and changed. Grouping the class describes a superclass. Next, 1.1 Object-oriented notions. This technology addresses the goals of the end users, analyst, programmers, and enable them to talk about the same things, in same frequency. Thus, the implicit requirements are, the objects should represent elements of the real world in terms of the properties and the actions that can be performed on the properties. In simple words, the grouping of data with its access methods is called an object of the object-oriented OOM technology. Next, class. A class is generalized description of characteristics of similar objects. It is template to create objects by invoking certain methods associated with the class. Objects of the same class have common operations, therefore, uniform in behaviors. Classes have one or more interfaces that specify operations accessible through that interface. A class body specifies code for implementing operations in the class interface. Next, class diagram. Class diagrams are the logical equivalent and similar in scope to relational data models. They show important business concepts, including the following: the data attributes needed, the behaviors each object exhibits, how the different objects are related. Next, the following types of class diagrams capture information about the business data. Business information model. These document a business subject areas, objects and attributes, as well as how these objects are conceptually related. These models generally don't capture behavior or are process-oriented, similar to logical data models of relational models. Next, business information model. These document a business subject areas, objects, attributes, and methods, as well as how the objects are conceptually related. These models include object behaviors in addition to data attributes, while relational data models do not capture behavioral characteristics of the business entities, although there is no direct mapping in relational models, but regarded closer to logical data models. Next, business object model. Represent the physical realization of a business analysis model, and model the software objects, with attributes, methods and inter-object relationships, and are made for implementation. In fact, this documents the physical design of the software to be built, and like to physical data models of relational models. Next, an example of class diagram is portrayed, name of entity, student and course with set of attributes, and measures respectively. Next, this image is object diagram's instance of in a related size student and his offered course measures, depicted, which are stored in separate entities but integrated. Next, object. It is an entity that has a well-defined role in the application domain, and has state, behavior, and identity. An object is software packet containing a collection of data elements and a set of procedures that are the only valid operations on that data. In plain words, objects always combine data and behavior. Once defined, objects can be used as basic data types within a program. Next, an object has a state, presents an interface, and exhibits a behavior. The state is determined by the value of object's internal data, which results from the operations performed on that data, and changes its state. The variables representing the internal state of an object are called instance variables. Next, states encompasses the details of the transition of objects from one business state to another. As such, these are represented by objects' properties, attributes and relationship, and the stored values of those properties. Next, behavior. It represents how an object acts and reacts, shown by operations in above class diagrams, while describing behavior of business processes. To elaborate, see note. Note, a programming object is a building block of functionality and data, where the combination of data elements and programmatic behavior allows objects to be relatively easily reused or recombined into different configurations. Next, encapsulation is a form of information hiding. It is a technique by which the data is packed together with its corresponding methods. This simply means that internal data of an object can only be accessed through the message interface for that object, and hides internal data from its requester. It is the technique of hiding the internal implementation details of any object from an external view. Next, inheritance is a code-sharing mechanism. It allows reuse of the behavior of a class in the definitions of new classes. Subclasses of a class inherit the data structure and the operations of the parent class, also called a superclass, and may add new operations and new instance variables. Next, inheritance, often referred to as an is-A relationship. If the class A inherits from class B, then it is possible to say that A is a B. Inheritance from single superclass is called single inheritance, from multiple superclasses is called multiple inheritance. Not all OOPLs support multiple inheritance. Next, messages, like a function call, are signals sent from one object to another that requests the receiving object to carry out one of its methods. Next, methods. Methodology breaks a system down into objects, embodying both data characteristics, attributes and process methods. Software programs become collections of interconnected objects, where those objects perform their individual functions and store their specific data independently. These objects are integrated into a program to perform meaningful task. In a way, methods are procedures contained within an object and executed in response to a message. Next, Segment 2, Unit 1, Object-Oriented Modeling, Foundation. A is over. Please.